Hello, my name is Michael Wickerson, and welcome back to Wickerson Studios. I am going into the Intermediate Advanced section of the one-liners for Python as applied to ghPython remote nodes in Grasshopper for Rhino 3D. So that's it in a nutshell. As I enter this chapter, I'm going to be importing more libraries, and this is Scikit-learn, sklearn, and scikit-learn linear models. I'm going to be using linear regression in an example. I'm going to be applying that to some very simple geometry, so you can start to actually consider using machine learning while generating geometries. But to start with, I want to jump back for a second and realize the necessity. This is the base script that I'll get into, and I'll do a video on this following this. But what I really want to focus on now is branch management and actually show you how to get into scripting. And I've got a nice little node here that's been pulled. I've looked online for it, and you can see very specifically what you would need. Now, this is a Wickerson Studio custom user object, but that's only because I've customized it a bit, so I made it a little different from what I found online, and I thought I'd throw that up in my on my ribbon tool. And this will be one of the first scripts in the intermediate advanced section. Remember, we will be going advanced, and we'll ending up with some very tricky algorithms in the end. But I want you to see the breakdown of this and try and wrap your head around it. It's been a long time, playing with a lot of path mappers, playing with a lot of trees, trying to get out with Python and get past the lists and deal with lists of lists. So here's a wonderful example of importing random, because I'll be using it. You must import the Grasshopper kernel data ghpath as ghpath if you want to be using the paths. You must download import in the data trees if you want to be using data trees, and you'll need system, Grasshopper Python library components as GHC, and then I have Rhino script syntax and Rhino geometry because I usually use those two imports quite a bit. Nest and paths are the two examples, and you see I've outputted them as nest and paths. You could output them as A and B, so it wouldn't be hard to just pull them in, but I think the more readable this script is, the better. It will still run if I output A and B. I don't know if it runs a little longer doing that. And you can see what's happening. Nest is going to equal the data tree system object as a list, and it's going to reference, and this will be the tree itself, the nest. And with that nest being a data tree, we need to add some jazz into it, and we'll need some paths, so we'll need a data tree systems object as well. And those are two data tree system objects that are necessary, and those are going to be your two outputs. So once they're defined, you can go into for alpha paths. Think of this as a nested loop. For alpha path, I've set in range, and num paths is a actual, you can see over here, is an actual input integer for number of paths. You could just hard code in a number, but it's better to make these things parametric. So I shouldn't say 3 alpha paths. I should actually say num paths alpha paths, which is the number of num paths for alpha paths. Then nested in there, you'll need a for loop for, let's say, beta branch, which will be a random branch that goes from start, stop, and step to those branches, and those are all parametric, so I can change those around. And we're going to show you the effects of this. Each gets a random number of beta branches. Then and within that, paths you're going to want to add, because you've got to add this to the list each time. A full path, add full path, so that should be add. Well, I guess add can have 2 Ds or 1 D. Add full path to alpha path, and you're going to be using the ghpath alpha path to do that. So this is a nice little script you got tucked in here. You're going to be putting branches into that. And then for item in range, the number of items, I made that parametric as well. I've got every slider set between 0 and 10. And you can see where it crashes out or where it doesn't work. And you'll need to use the alpha path and the alpha branch to do that and assign a number to given path. So that's it. How do you call? And I do have a question here. How do I call all beta branches from alpha path 0? And I put that question mark in there because I just asked myself that question. But for paths in paths branch 0, I will print the path, and I will also print the nest branch ghpath. So you're going to see those things come up in the outcomes. And that's exactly what you get. And you get nicely here, you'll see the call I will be getting, because of the 2 prints, I will get the path, which is 0.0 of branch 0. Let's change this to 1 and see what happens there. And that changes obviously the 1 path. And what happens if we change this to 4? I'm not sure. Yep, 4. And then we start popping in, and there seems to be these added listed items because I've made more branches. So I'm going to leave it at 0. So you can play around with these numbers, and I can make that parametric as well for pile path 0, but I think I'll leave that for now because I'm calling to call all branches. So I could have a calling branch parametric in here as well, but I think I'll leave that off because it's getting a little nested and complex in my mind. Then I'm going to want to print the nest branch alpha path, and that's really nice because that'll show you exactly you have a list objects. Let's run it again to get it back down to where it was. List objects from the list 0 through 5. So let's hit OK, and let's open this up. And let's make this a little longer. Actually, I think what I'll do is just bring it out here. What is going on? Oh, sorry. Sometimes I'll lose my mind. Let's pull these over here, and we'll take these items. Grouping is always so crazy. You gotta select, select, select. Let's pull that over here, and let's pull this one over here. And now we've got some parametric models, and let's make them a little bigger so we can look at them. The tree is nice. I guess we can make it bigger to look at since we have a bigger model. It's always nice to visualize the tree. And then let's move that over here and pull this branch up here so we can really see what we're creating. So here we are. Let's start with 5 number of paths. Let's do 3 number of paths. Let's do 2 number of paths. Let's start it at, you see how it crashes out if it goes ahead of the number. So this has always got to be more. So you might want to make this parametric so this number always stays as an added number to this one. But if we went from 3 to 10 branches, as choice for start, stop, and step, we could always step it up and change the numbers within there. And every time you run the script, it's going to do another random because random is set into the script. And then also how many we want. 6 paths, we can go as many as we want. So what a wonderful way to jazz and create some really interesting trees. Look at how complex these things get when you start do-si-doing these numbers up too high. But you've got also the sense that you can go in here and run the path. Just keep running the path, test, get another set, another set. So if you're interested in generating trees for yourself and multiple trees, get in here and play with that branch management. I think this is a wonderful tool just for actually getting in there and having fun with it. So I'm going to leave that a little bigger. I'll hit save on this. This will be my linear regression 001 intermediate advanced script to start. Now we'll jump in and we'll do another 001. I think, actually, I shouldn't have changed the intermediate. I should have actually had this as a script on intermediate advanced. This is the one I should have been playing with, branch management. But needless to say, you'll figure it out, and I'll always have these master files when you're done that'll hold everything. Now we're going to go into this one, branch management, but we'll probably put it on to the intermediate advanced. We're going to go into details about what this means to import the scikit-learn library and module, and then we're going to show you the base script that's in place. We're going to take a lot of notes on machine learning, and then we're going to show you scikit-learn and what that does to geometry and what you're actually thinking about when you're running a script like a linear regression one-liner. And you can see how interesting this is. Model is linear. I call it linear model. I can pull as a method or a function from that linear regression, which then has within it fit. It has a reshape tool, and then you're able to predict the outcome. And we're going to get into this on the next one, so stay tuned. Thanks very much for watching. And I'll just do a little jazz there to pull it all in.